Joining us now from NASA's Goddard Space Flight Center is Dr. Tom Wagner, who's going to tell us a little bit more about Arctic sea ice. Thanks for joining us.
Hey, thanks for having me.
So last year was a record-breaking year for sea ice loss in the Arctic. What are we seeing this year?
Well, the good news is we're not on track for another record. But the bad news is the ice didn't really heal up anyway, and it's still shrinking to one of the lowest years on record and about the thinnest ice we've ever had as well.
So what does the long-term trend look like?
The long-term trend is this. If you go back to like the 80s, we've lost more than half the sea ice that used to be around in the 80s. And we're continuing over this last decade this ever-increasing loss of ice during the summer, but also this startling thinning that's been going on as well. And so there's people who talk about, hey, are we going to be reaching ice-free summers in the next few years? Probably not. We'll probably always form some ice at the North Pole where it's cold. But the point is, there's so much ice loss that the Arctic is in a new state.
But the Arctic is far away. How does sea ice melting impact us in the United States or globally?
Loss of Arctic sea ice is profoundly important for the globe for a number of reasons. First of all, it's one of the biggest knobs on global weather. This is one of the biggest physical changes on Earth. We have an ocean that used to be covered with a solid surface that's going away. It affects the position of the jet stream, which will now extend further north and further south and cause blocking patterns that could increase those periods of extreme heat and extreme cold in the US. But that's just kind of the simplest thing. It could also affect storm tracks like Superstorm Sandy. It could also affect globally those weather patterns, and those are the kind of cutting-edge research questions that we're working on right now. But also, too, the Arctic has massive stores of methane in the permafrost and also on the seabed. As we lose the sea ice, we have more heat going into the ocean, and we can also transport that heat, cause more permafrost thawing, destabilize the seabed, and potentially trip the release of all this methane, which could cause big spikes in global temperature. Also, too, the Arctic is overall the canary in the coal mine. The polar regions heat up faster than the rest of the planet. Basically, in the tropics, they're getting warmer too, but that heat gets advected up into the atmosphere and gets pushed north and south. So the polar regions are kind of the place where you would expect to see right away the warming effects really take place. And that's exactly what we're seeing in the Arctic. And finally, the Arctic is just one of the most fascinating, least explored places on Earth. You know, you have the amazing animals like polar bears, you have these unique whales like the narwhal, and you have this really interesting ecosystem involving things like algae forming near the surface and sinking to the bed and creating this rich benthic environment that walruses then come in and exploit. And all of that is changing right now in real time.
So tell us, what is NASA doing to better understand what's going on in the Arctic?
NASA does a couple of different things. First and foremost are the satellite studies, and we use a range of satellites to document the sea ice and understand its connection to the global drivers of change. We also have some of the most sophisticated research aircraft in the world, and we fly over the ice and shoot at it with lasers and radars, and we have other devices to measure variations of the Earth's gravitational field and magnetic field, all to understand what's going on with the ice. We don't just work on the sea ice, we also study the glaciers of Alaska, the Canadian ice caps, and the Greenland ice sheet, where there's been a lot of changes in recent years.
Can you tell us a little bit about some of the changes in Greenland?
So last year, for the first time in the record, we had extensive melting across the entire surface of Greenland, even the really high cold parts. Also, too, our satellite data shows us that Greenland is not just losing more ice, it's accelerating in its ice loss, and it's losing ice not just from the warm south, but also from the cold northern regions. And what people need to understand is that this isn't just one study or one type of data. We bounce lasers off the ice to measure the height. We use radar to study how fast the ice is flowing. And we actually use a satellite called GRACE, which is a pair of satellites orbiting the Earth that directly measure the mass change itself. And we have people out on the ground walking around and looking at this and banging GPS devices in and looking at how fast the ice is flowing into the ocean. And the simple fact is we're losing a lot of ice out of Greenland.
What can you tell us about Antarctica?
Antarctica is also a fascinating place, and we're losing a lot of ice from Antarctica, particularly West Antarctica. With East Antarctica, it's a little bit more ambiguous. The problem is, again, we're characterizing continental scale areas, and we're looking at subtle changes in ice. In some areas along the coast, from satellite, we can see that we're losing 30 feet of ice a year. Some of this, though, is balanced by the amount of snowfall that falls in the interior of Antarctica, and we're working out that balance now. But overall, Antarctica looks like it's losing a lot of ice. Also, too, there's sea ice that surrounds Antarctica that's kind of analogous to the sea ice at the North Pole. The thing is, though, every year the Antarctic sea ice grows and then almost all of it retreats. But in recent years, there's been a little more growth of sea ice in some areas, and so overall the Antarctic sea ice has been increasing a bit. But it's a very different thing than what's going on in the Arctic.
Where can we learn more about all this?
One of the best places to go is nasa.gov/earth, and you can also go to ice.nasa.gov.